Dynamic programming. It sounds futuristic, like robots making decisions. Spoiler, it's not. Instead, it's a method that stops computers from working harder than they need to, making them look impressively competent in the process. At its core, dynamic programming is about breaking problems into smaller pieces, solving each piece once, and remembering the answers so they don't have to be recalculated later. Think of it like a student who actually remembers their homework answers and doesn't need to redo the same problem 15 times. It relies on two core principles. One, recursion, a fancy way of saying, let's solve a small part first, then use that to solve the bigger problem. Two, memoization. Remember what we've already done so we don't do it again. Together, these create a structured, logical way to tackle problems that would otherwise take an absurd amount of time to solve. Dynamic programming isn't just an abstract idea. It powers everything from route optimization in GPS systems to predictive models in finance and healthcare. It's the reason Google Maps can find the best path instead of all paths. Your streaming service doesn't buffer every time you rewind. Its superpowers include efficiency, prevents your computer from being uselessly inefficient, which, let's be honest, it would be if left unchecked. Versatility, used in AI, bioinformatics, economics, game development, you name it. Decomposition trains programmers to think logically, breaking big problems into bite-sized, solvable chunks. Imagine you're at a shop with coins of 1, 2, and 5 units, and you need to make 11 units using the fewest coins. If you grab coins randomly, you might end up with a pocket full of change and no real progress. A brute force approach would involve testing every combination. That's terribly inefficient. Instead, dynamic programming builds a solution step by step. Start with the smallest amount. Store the minimum number of coins needed for each total. Use past solutions to construct the next step. By the end, you get an optimized solution, 2 5-unit coins and 1 1-unit coin. No unnecessary calculations required. Now that we've covered the foundation, we'll move on to real-world problems that dynamic programming solves effortlessly. You'll see how a few simple principles turn seemingly impossible problems into structured solutions. This isn't just about algorithms. It's about thinking smarter, and that's something every programmer can benefit from. I am your guide, Antonio Klim. May the pseudo powers be always with you.